Part 1. Introduction. Discovering a mysterious phenomenon. One summer morning in 1908, the clear blue sky of the deep Siberian forest suddenly lit up strangely, turning the still air into chaos. The explosion was as loud as thunder. The ground shook violently. A large area of forest, stretching over 2,000 square kilometers, was flattened in an instant. The indigenous Evenki people and Russian foresters witnessed this strange scene in shock. That is the famous event known as the Tunguska explosion, one of the biggest mysteries that has not been fully explained to this day. This explosion not only attracted attention because of its terrible destructive power, equivalent to 10 to 15 megatons of TNT, about 1,000 times more powerful than the Hiroshima atomic bomb, but also because of many other special features. No obvious impact crater, no meteorite fragments or strange objects were found, no major casualties due to the sparse population of the area. After more than a century of research and debate, the Tunguska event is still a big question mark for scientists and enthusiasts of mysterious phenomena. It is a vivid demonstration of the potential power of celestial bodies when they come into contact with Earth, as well as an early warning of dangers from outer space. This article will present a comprehensive account of the Tunguska event, from its history, the scene, scientific and non-scientific hypotheses, to modern analysis and lessons learned. Hopefully, through this, readers will have a deeper insight into one of the most mysterious disasters in human history. Part 2. The Tunguska event and scene. The first evidence, on the morning of the 30th of June 1908, according to the Gregorian calendar, the sky over the Tunguska region, in central Siberia, Russia, suddenly lit up brightly, brighter than the sunlight during the day. A loud explosion caused the ground to shake over a large area. The shock waves spread out, creating a swirling wind, sweeping away everything in its path. The explosion occurred at an altitude of about 8 to 10 kilometers above the ground. Evenki locals reported that the sky lit up strangely, accompanied by a thunderous explosion, followed by a strong wind that blew many people away. Ancient trees tens of meters high were blown down in a certain direction, creating a forest area that was more than 50 kilometers long. The forest area of over 2,000 square kilometers was completely flattened. Trees were blown down like dry leaves, forming a shape like a large fan spreading out. The devastated area was equivalent to the area of a large city like Ho Chi Minh City today. The shock wave from the explosion could be felt at a distance of up to several thousand kilometers. Seismological stations in Europe also recorded a seismic event similar to a major earthquake. Notably, there was no obvious impact crater on the ground. Scientists who later arrived at the site also did not find large meteorite fragments or other foreign objects. This is an important and controversial difference. In 1927, explorer Leonid Kulik was assigned to investigate the Tunguska explosion. He led the first expedition to the site, bringing with him seismometers and recording equipment to collect data. Kulik met with local people and recorded their accounts of the event. Although Kulik had high hopes of finding a meteorite crater, he only found an area of fallen forest, burnt trees, and altered soil. This made him and his colleagues rethink the theory that the meteorite had hit the ground directly. Part 3. Hypotheses about the cause of the Tunguska explosion. This is the most widely accepted hypothesis by mainstream science. Accordingly, a meteorite or comet fragment, about 50-60 meters in size, crashed into the Earth's atmosphere at a very high speed. Friction and pressure caused the meteorite to burn violently and explode in the air at an altitude of about 8-10 kilometers. This explosion created extremely strong shock waves, flattening a large forest and causing widespread tremors. The explosion in the air caused the meteorite to be scattered without creating a clear impact crater. Aerodynamic simulation models and field data have supported this hypothesis. Some researchers of the mysterious school propose that the Tunguska explosion was the result of a high-energy weapon test conducted by an extraterrestrial civilization on Earth. They rely on the large destructive power, the absence of impact craters, and the surrounding mysterious phenomena to make this hypothesis. However, there is currently no solid scientific evidence to support this hypothesis, and it is often dismissed by the mainstream scientific community due to lack of clear basis. Nikola Tesla, the great inventor with many works on electricity and energy, was once said to have had the idea of testing high-energy weapons. Some conspiracy theories claim that Tesla tested a device that generates electromagnetic waves or air weapons in the Tunguska region, leading to the explosion. However, there is no official document or convincing evidence to prove this. This is still a hypothesis of legendary nature and is associated with the mystery surrounding Tesla. Part 4. Analysis and modern technology in the study of the Tunguska explosion. In recent decades, with the development of computer technology, scientists have used aerodynamic and physical simulation models to recreate the Tunguska explosion. These simulations help determine the size, composition, approach angle, velocity of the celestial body, as well as the mechanism of explosion in the air. The results show that the celestial body could be a rocky meteorite or ice comet, exploding at an altitude of about 8 to 10 kilometers, causing enormous destructive power as observed in reality. After the Tunguska event, many areas around the world recorded the phenomenon of the sky glowing at night for weeks to months, due to a large amount of dust and particulate matter flying into the stratosphere. Analysis of atmospheric and climate data shows temporary changes in global weather patterns, affecting temperatures and meteorological phenomena. This demonstrates the wide-ranging impact of the explosion, not only in the surrounding area but also on a global scale. The Chelyabinsk meteorite explosion that occurred in 2013 inches, Russia had an explosive power of about 500 kilotons of TNT, much smaller than the Tunguska explosion, but was recorded by many modern devices, such as cameras and seismic sensors. This explosion provides real evidence for the hypothesis that the meteorite exploded in the air, did not create an impact crater but caused strong shock waves, causing more than 1,500 people to be slightly injured by broken glass. This comparison helps scientists strengthen their understanding of the Tunguska explosion mechanism. Part 5. Impact and lessons from the Tunguska explosion. The explosion caused severe environmental damage, destroying thousands of square kilometers of old-growth forest, seriously affecting the ecosystem and the lives of local creatures. However, over time, nature in the affected area gradually recovered, with trees growing back and animals returning to life, demonstrating the miraculous recovery ability of nature after a disaster. The Tunguska event serves as a warning to humanity about the dangers from celestial bodies, which can appear suddenly and cause serious damage. Since then, organizations such as NASA have established the Near-Earth Object Observations Program to monitor, detect, and provide early warning of objects at risk of collision. International programs have also been coordinated to enhance planetary defense capabilities, with options such as diverting asteroids and destroying them when they are still far from Earth. The Tunguska explosion has spurred multidisciplinary research, from astronomy, geology, meteorology to space technology. It has inspired studies on meteorite impacts, atmospheric shockwave effects, and environmental impacts. Part 6. Conclusion and legacy of the Tunguska explosion. More than a century has passed. The Tunguska explosion remains one of humanity's greatest mysteries. This is a vivid demonstration of the terrible power of celestial bodies when colliding with Earth, and also a reminder of the fragility of the blue planet in the face of natural disasters. Although no impact crater or large meteorite fragments were found, thanks to modern technology and precise simulations, we have been able to partly understand the explosion mechanism, as well as its diverse impacts on the environment and atmosphere. Tunguska is an important milestone in the history of meteorite and space collision research, and is an inspiration for modern science and technology to develop to monitor and protect the Earth. Valuable lessons from this explosion will continue to accompany humanity on its journey to explore the universe and protect our common home.